Yellowstone gets all the attention. But what if I told you that there are supervolcanoes even larger and far more complex, hidden across the planet? Most natural hazards we study have limits. A big earthquake can only get so big, and a hurricane eventually runs out of warm water. But volcanic systems? Those don't always play by the same rules. Beneath the surface of our planet, some volcanoes have left scars so large, so deep, that they reshape entire landscapes in a single geological breath. These aren't normal eruptions. They're not even large eruptions. These are events so massive they sit at the very top of the Volcanic Explosivity Index, VEI 8. These are what we casually call supervolcanoes. Not because they're special structures, but because the eruptions they produce are in a class of their own. Eruptions measured in thousands of cubic kilometers of material. It's enough ash to blanket continents. Enough energy to collapse entire sections of crust. And enough geological force to leave scars that remain visible for millions of years. Before we go any deeper, if you want more science-based breakdowns of the forces that shape dangerous Earth, make sure to subscribe. It helps the series grow and supports more episodes just like this. But let's get into the real story behind these giant eruptions. A supervolcano is not a shape, it's not a mountain waiting to blow. It's a volcanic system capable of producing a VEI 8 eruption. That's it. Volcanoes don't erupt because they're due. They erupt when conditions deep in the crust allow them to. At the heart of every VEI 8 event is a massive magma reservoir. Not a giant open cavity, but a complex mixture of melt and crystals spread through the weakened crust. Over tens of thousands of years, magma accumulates, reheats, mixes, and slowly evolves. Most of the time, nothing at all reaches the surface. The system breathes, leaks heat, shifts, and readjusts. Its hot springs, fumaroles, and ground deformation are signs of this constant background activity, not warnings of a catastrophe. But when these systems do reach the right conditions for a giant eruption, the sequence is unlike anything smaller volcanoes experience. Pressure builds across a wide area of crust. The surface slowly domes upwards, fractures begin to propagate, and eventually, the roof of the magma reservoir collapses inward. That collapse ejects enormous volumes of magma in a geological instant. Ash reaching more than 30 kilometers into the atmosphere, pyroclastic flows traveling tens of kilometers, and the formation of a caldera that can be tens of kilometers wide. But here's the part that gets overlooked. These eruptions are extraordinarily rare. Yellowstone's last one was 2.1 million years ago. Taupo's was more than 26,000 years ago. Most caldera systems will experience just one or two events of this scale over their entire lifespan. And between these monumental eruptions, the same systems typically produce much smaller ones, VEI 3 to 6, the type of eruptions that matter on human timescales. And it's also important to understand that a super eruption is not an instant global extinction event. The Toba eruption around 74,000 years ago was massive and likely caused years of cooling. But ecosystems survived. Humans survived. The Earth recovered. These events reshape regions and push the climate temporarily, but they don't end the world. After these eruptions, the story doesn't end. New magma intrudes, lakes fill the crater, and forests reclaim the edges. Over thousands of years, the landscape transforms again, turning a site of catastrophic collapse into a stable, evolving environment. These systems aren't defined by destruction alone. They are part of Earth's long, slow cycle of renewal. So, what is a supervolcano? It's not a doomsday machine. It's not a volcano waiting to wipe out humanity. It's just a name we give to the largest eruptions Earth can produce. Rare, powerful, and deeply tied to the planet's internal engine. Studying them isn't about predicting the next cataclysm. It's about understanding how magma moves, how crust fails, and how Earth reshapes itself on scales far bigger than our human world. If you learned something new here, subscribe and share this video with someone who loves Earth science. It helps the series reach more people and supports the channel. Thanks for watching, stay curious about the planet beneath your feet, and I will see you in the next one.